Hello grade 12 American System, this is Mrs. Nancy. Today I'm going to start a new section in chapter 23, section 23.1, Introduction to Functional Groups. The objectives of this section are: explain how organic compounds are classified, identify the general formula of a halocarbon, describe how substitution reactions are used in organic chemistry. So please open your book, page 798. What is a functional group? A functional group is a specific arrangement of atoms in an organic compound that is capable of characteristic chemical reactions. Most of organic chemistry involves the functional groups of organic molecules. Organic compounds can be classified according to their functional groups. This table identifies the functional groups that you will learn about in this chapter. In each general structure listed, the symbol R represents any carbon chains or rings attached to the functional group. In some cases, R can be a hydrogen atom. When more than one R group is shown in the structural formula, the groups do not need to be the same. According to the table, the compound type halocarbon has a general structure Rx, where X is fluorine, chlorine, bromine, or iodine, and the functional group is halogen. Alcohol, ROH, functional group hydroxy. Ether, ROR, functional group ether. Amine, RNH2, functional group amino. Aldehyde, RCOH, functional group carbonyl. Ketone, RCOR, functional group carbonyl. Carboxylic acid, RCOOH, functional group carbonyl. Ester, RCOOR, functional group ester. Amides, RCONR2, functional group amide. Halocarbons. A halocarbon is an organic compound that contains at least one covalently bonded fluorine, chlorine, bromine, or iodine atom. The general formula of a halocarbon is Rx, where X is a halogen substituent. The IUPAC rules for naming halocarbons are based on the name of the parent hydrocarbon. The halogen groups are named as substituents. Common names of halocarbons consist of two parts. The first part names the hydrocarbon portion of the molecule as an alkyl group, such as methyl or ethyl. The second part names the halogen with an "-ide" ending. Let's take an example. Look at the first example below. Methyl chloride. The alkyl group is CH3 and the second part is the halogen chlorine. The second example is vinyl chloride and the third example is phenyl chloride. A halocarbon in which a halogen is attached to a carbon of an aliphatic chain is called an alkyl halide, while a halocarbon in which a halogen is attached to a carbon of an arene ring is called an aryl halide. The attractions between halocarbon molecules are the result of the weak van der Waals interactions. So, the more highly halogenated organic compounds, they will have higher boiling points. This table lists the names of some substituent groups other than methyl, ethyl, and propyl. Example: isopropyl, isobutyl, secondary butyl, tertiary butyl, vinyl, and phenyl.